So let's move to second transformation. Okay, so if we have ft equal to t to the power of n. Okay, now just now we have ft is a constant, ft equal to a. Okay, now let's say we have ft equal to t to the power of n, where this one is a polynomial. Maybe you can have ft equal to t to the power of 2. Maybe you can have ft equal to t to the power of 3, let's say. Okay, so the formula to find what is the Laplace transformation of ft, okay, is equal to n factorial over s n plus 1. So what is the important thing you need to know when you find the function in terms of polynomial like this is you need to know what is the value of n. Okay, then you can just substitute the value of n in the formula for Laplace transformation. Okay, let's say we have the simple one, ft equal to t to the power of 15. Okay, let's say 15 is too big. Okay, let's say we have ft equal to t to the power of 3, for example. Okay, so now from this polynomial you can see that the value of n that you have is 3. Okay, your n is equal to 3. So now to find the Laplace transformation for t to the power of 3, okay, Laplace transformation for t to the power of 3, what you will have is n factorial. So your n now is 3, so 3 factorial over s to the power of n plus 1. So your n is 3 plus 1 is 4, so s to the power of 4. So 3 factorial you can calculate by using calculator, you will get 6. So your final answer is 6 over s to the power of 4. So what is this? What is the 6 to the over s to the power of 4? 6 over s to the power of 4 is fs, where fs is the Laplace transformation of ft. Okay, let's see example here. Let's see example B here. Okay, example B, we have ft, we have gw, okay, equal to 2 over 3w to the power of 7. Okay, when you have this type of equation, you can simply bring 2 to the power of 3 here in front, because this one is a constant. Okay, so when you want to find what is the Laplace transformation of your function gw, okay, you can write it like this: 2 over 3 Laplace transformation of w to the power of 7. Okay, so now you can say that w to the power of 7 is the polynomial with power 7. Okay, so your n here is equal to 7. Okay, so to find the Laplace transformation for the polynomial, we can use the formula n factorial over s n plus 1. Okay, therefore we just need to substitute. So don't forget that we have 2 over 3 in front here. So the Laplace transformation for w to the power of 7 is n factorial. So we have 7 factorial over with s n plus 1. So n plus 1 is 8. So this one is the Laplace transformation. So now you just need to find what is the value of 7 factorial and simplify this fraction. Okay, so what you will have for 7 factorial is, let me calculate. 7 factorial is 2 over 3. 7 factorial is equal to 5040 divided by s to the power of 8. So let's check whether we can. So this one can be simplified, it become 21680 s to the power of 8. So your final answer will be 3360 over s to the power of 8. So this one is the final answer. Okay, So let's see the example C here. Okay, so example C, we have CU is equal to set 14 u to the power of 2. Okay, don't worry too much when you see set 14 here, because set 14 is just a constant. Okay, we can just bring it in front of the Laplace transformation process. Okay, so now if we want to find the Laplace transformation of CU, okay, you want to find the Laplace transformation of CU. Okay, what you will do here is you bring to the front set 14, because this one is just a constant. Then you find the Laplace transformation of u to the power of 2, where u to the power of 2 is the polynomial. The step that important is you need to know what is the n. So here and your n is equal to 2. Okay, so let's use the formula for Laplace transformation of polynomial. Therefore, you will have your fs. The Laplace transformation of ft equal to set 14 times with 2 factorial over s to the power of 3. Okay, therefore, you will have set 14 times with 2 over s to the power of 3, and your final answer will be 2 set 14 over s to the power of 3. So this one is the Laplace transformation of your function set 14 u to the power of 2. So now you see that in your, after you have done a Laplace transformation process, your term will be only in term of s. Your function will be only in term of s. So this one is the property, the second property of Laplace transformation. The third Laplace transformation, okay, for the third Laplace transformation is for the function where it involves exponential function. Okay, so let's say we have the function ft equal to exponent at. Okay, to find the Laplace transformation of ft, or the symbol of Laplace transformation if fs, the formula will be 1 over s minus a. So if you see to add the formula here, the important thing that you need to know from your function is the value of a here. Okay, you need to know the value of a, then you can substitute inside the formula here. Okay, so let's see one example. Let's say we have a function gd equal to exponent negative 18d. Okay, don't worry, because this is the function of g in term of t, that's why you have d here. Okay, if you have a function f in term of t, then your inside your equation will be t. When you have a function g in term of d, therefore inside your equation is a variable d. Okay, now we want to find the Laplace transformation for the function gd. So we want to find what is our gs. Okay, so we want to use this formula, but to use this formula you need to know what is the value of a. So here your value of a is equal to negative 18. Therefore you just need to substitute inside your formula. So what you will have here is 1 over s minus negative 18. Don't forget to take together the negative sign there. So what is your Laplace transformation is 1 over s plus 18. Okay, by using a formula. Let's see example C here. So we have now the function vt equal to 4 over 3 exponent negative 8t. Okay, like I said you before, don't worry about the constant in front, because we can take it, bring it out of the Laplace transformation process. Okay, so to find what is vs, okay, to find what is vs, we bring out 4 over 3 because it is a constant. We need to do a Laplace transformation on exponent negative 18. So when this involves exponent, we know that the formula that we can use is 1 over s minus a. Now what is our a? Our a is negative 8. Okay, therefore we can use the formula for exponential function. We will have 4 over 3 in front here and 1 over s minus negative 8 at the back. Okay, so when you expand the fraction here, what you will have is 4 over 3 times with 1 over s plus 8. Okay, so you will have your final answer as 4 over 3 vs plus, so this one is your vs, or the Laplace transformation of your function exponent. Okay, so this one is the third function.